But for example, let me talk about one called erythropoietin, which is also called EPO, which sometimes you hear about in cases of sort of athletes doping, taking drugs that they shouldn't to enhance performance-enhancing drugs. Erythropoietin is, in fact, one of them, and I'll talk about why. So erythropoietin is a hormone that is one of many growth factors. It is what it actually, its chemical nature is it's a small protein growth factor. And it's produced by your kidneys, by kidney cells, when the number of red blood cells is low. And it stimulates red blood cell producing cells to divide. Let me write that more neatly and I'll explain it in a second. Rapidly, and that leads to more RBCs, or red blood cells. So here's a sort of classic example of homeostasis. So red blood cells carry oxygen in your blood. We all know that. They turn over. That is, they're processed by your liver and a variety of other organs to remove them as they get sort of worn out and they get turned over. You need to maintain a certain level in your blood, otherwise you're not going to get enough oxygen. Right? It's not automatic. It has to be regulated. Your kidneys, as it turns out, have sensor cells in them, and that when your level of red blood cells gets too low, they sense that, and they turn on the expression, of the gene for erythropoietin. So the gene gets transcribed, it gets translated, they make the protein erythropoietin, and they secrete it out into the blood. It floats around to the cells of usually your long bones in your legs and the like, are where red blood cells get made. And in there are cells which don't divide most of the time, unless they see erythropoietin. When erythropoietin comes along, it stimulates them to divide. And when they divide, their daughter cells go on and become red blood cells. So in the presence of erythropoietin causes more red blood cells to be made. So then the level of red blood cells climbs up, and eventually your kidneys quit making the erythropoietin gets degraded, and the signal stops, and then you stop making them until you need them again. And so this is a way to modulate the amount of red blood cells you have. So for example, if you've done a blood transfusion, right? You've given blood, if you donated blood, you're down a pint or whatever, you would expect your kidneys to secrete a lot of erythropoietin, stimulate more production of red blood cells. Right? And that builds your level back up until then it's the level it's supposed to be, and then that whole business shuts off. You can also see why this might be a performance-enhancing drug. That is, sometimes athletes inject themselves with extra erythropoietin to stimulate extra red blood cell production so their blood has extra oxygen carrying capacity. Problem with that is if the level gets too high, then you actually can get blood clots and strokes and heart attacks and all kinds of nasty stuff because your blood vessels gum up. So the level is regulated relatively carefully. In any case, this is a classic example. And there are lots of other ones, like there are epidermal growth factors. So if I get a cut, and I need to replace some of my epidermis, some of my skin, then the cells in the neighborhood produce epidermal growth factor, stimulates the cells in your dermis, the lower layers of cells, to divide and fill in that space. So every cell type that can grow has its own set of growth factors designed to turn it on and off when you need more or less of those cells. So that's the normal situation that's supposed to happen in your body. Questions about that before we talk about how things like that can go wrong? Yeah?
Just a medical thing that I remember hearing on the femur. You said like one of your largest red blood cell producing bones in your body.
Right.
Would the erythropoietin basically affect your femur in a way too?
So if your femur is a bone where most of the red blood cells are made, would erythropoietin affect the bone growth, for example? No. It acts only on the cells that make red blood cells. So that the size, no, it's not. The effects are very specific, I suspect.